Hi everyone, I'm Smiling Rockets. Welcome to our channel. Let's take a look at this thing. Hello, Xiaoji.
Hello, I'm Potato. How's your day going?
Switch to work mode.
Okay, work mode is on. Volume is higher now. Better for working. Need any help?
Switch to camera mode.
Camera mode on. Volume is lower now, so it won't disturb your photos or videos. Ready to shoot something now.
Watch this. The AI camera can recognize objects in real time. It can even recognize human faces. We can see these smart devices are quietly entering our daily lives. AI makes machines see clearer, hear finer, and understand deeper. Behind this is a revolution in sensing technology. The UniHiker K10 with Xiaoji inside is an AI main control board. Unlike a regular development board, it's a super brain with a built-in thinking engine. It allows complex AI algorithms to run fast, directly on the device. Husky Lens is a sensor with algorithms inside. It's no longer just eyes or ears. It instantly transforms raw data into intelligent perception. Now, machines can truly see and hear the world. DFRobot is bringing AI into open source hardware, breaking down the height of innovation and making it within everyone's reach. Before stepping into AI development, many people start with a traditional Arduino board. For example, there's the DFRobot Arduino starter kit. It comes with a Uno main control board, an LED, a servo, and a buzzer, and 35 common components. Plus, it has 30 lessons with diagrams and text. Step by step, you master circuits and coding basics. It's not an AI board, but it's perfect for beginners. You learn how sensors work, how to control actuators, and build a solid base for AI later on. Now that we've lit up the lamp and spun the motor, it's time to make our board smart. Next, let's explore the secrets of AI boards. Why are they better for image recognition and voice control? So, what exactly is an AI board? In simple terms, it's a development board optimized for AI tasks. At its core, it has AI acceleration hardware like an NPU or GPU. It also has big memory and rich sensor interfaces. The biggest difference from a normal board is that AI boards can run AI locally without cloud servers. That cuts latency and makes data safer. They support various neural network models, especially strong in image recognition and speech processing. For example, this Fire Beetle 2 uses ESP32S3. It has 16 megabytes of flash and 8 megabytes of PSRAM, which is enough for complex AI applications. More importantly, AI boards support multimodal interaction. They process data from the camera, mic, and screen all at the same time. This enables more advanced AI applications, just like this UniHiker M10 in my hand. It has a 2.8-inch screen and supports Python teaching, which is great for AI education and rapid prototyping. Now, let's compare AI boards versus normal boards. First, let's talk about hardware performance. AI boards have dedicated AI accelerators. For example, the ESP32S3 supports vector extensions for AI tasks. But normal boards, they just have a basic MCU, so no AI acceleration. Second, memory capacity. AI boards carry large PSRAM. For example, the Fire Beetle 2 ESP32S3 has 8 megabytes of PSRAM, which is good for storing image frames or neural nets. Normal boards only have small SRAM. They can only handle simple data collection and control. Third, interface expansion. AI boards reserve ports for the camera, screen, and mic, so they're ready to use. Modules plug in directly. Normal boards, you must wire external modules, which is more complex and easier to get unstable. Fourth, application scenarios. AI boards suit image recognition, voice control, and Bluetooth mesh networking. Normal boards are more for simple sensors and basic logic tasks. Now, regarding power use, although AI needs more compute, hardware acceleration makes AI boards more efficient. They save more power than software-emulated AI, making them perfect for battery devices. Finally, let's consider the learning curve. Today's AI boards support MicroPython and Arduino. Deploying AI models is very easy. Normal boards, you'd need to write low-level code. and even build AI functions yourself, which is not beginner-friendly at all. In summary, AI boards are not just an upgrade to normal boards. They're a new hardware platform, specially optimized for AI. If you want voice recognition, image processing, or other advanced features, AI boards are the better choice. Now, let's demo some real products. First, the FireBeetle 2 ESP32S3 paired with the OV2640 camera. It does real-time face detection. In the Arduino IDE, just a few lines of AI library code give you professional face detection. Notice this. The model runs directly on the ESP32, so no cloud server is required. Next, let's take a closer look at the UniHiker K10. It's especially suitable for education and rapid prototyping. With the MindPlus graphical programming platform, students can build their own voice control programs just like stacking blocks. There's no need to write complex code. They can create AI applications on their own. The screen shows recognition results in real time, greatly lowering the entry barrier for AI learning. The K10 also supports speech synthesis. Its onboard speaker can play custom voice commands, enabling richer human-machine interaction. From maker projects to classrooms, AI boards make complex AI technology truly within reach, opening up endless possibilities for innovation. Now, when you're faced with many AI boards on the market, how do you choose the right one? Well, the key is to start from your own needs. If your project focuses on IoT plus AI, then the FireBeetle 2 is an ideal choice. It comes with Wi-Fi and Bluetooth dual mode, supports low power operation, and is perfect for smart devices that need networking and long working hours. If your focus is education or rapid prototyping, then I personally recommend the UniHiker K10. It integrates many sensors and a camera, so developers can start creating right away without needing extra accessories. And the graphical programming environment further lowers the entry threshold. From a developer's perspective, beginners can use MicroPython or Arduino's rich ecosystem to get started quickly. Advanced users can choose ESP-IDF for deeper, low-level development, even customizing neural network models to unleash the full potential of AI boards. Whether it's smart home control, machine vision, voice interaction, or education and research, choosing the right AI board will make your project twice as effective. Next, let's turn our attention to the intelligent revolution of sensors. From smart home voice control to elderly fall detection in health monitoring, to autonomous vehicles identifying pedestrians and obstacles, the world around us is being redefined by more and more smart sensors. And the core question of this transformation is, how do traditional sensors evolve into thinking AI sensors? For example, this millimeter wave radar in my hand not only detects human presence, but through point cloud algorithms, it can also accurately determine whether a person has fallen. For example, this HuskyLens Vision AI module can recognize multiple objects in real time and even distinguish between different faces. And this offline speech recognition module, it needs no internet, yet it can accurately understand and execute voice commands, providing a more natural way to interact with smart devices. The arrival of these smart sensors is completely changing how we interact with technology, allowing machines to truly understand our world. Now, to grasp the revolutionary nature of AI sensors, we first need to understand the essence of ordinary sensors. An ordinary sensor is essentially a converter. It takes signals from the physical world, things like temperature, light, or motion, and converts them into electrical signals for electronic devices to process. Let's take this BME 688 environmental sensor as an example. It measures temperature, humidity, and gas concentration. If it only outputs raw data, then it is nothing more than a standard gas sensor. Such a sensor might only tell us current temperature 26 degrees Celsius, humidity 87%, but it cannot tell us whether the smell is coffee or whether it is mango. Normally, these raw data must be sent to a microcontroller or cloud server for further analysis and decision making. The whole process takes time and relies on external computing resources. By contrast, our AI sensors achieve deep integration of hardware and algorithms. They not only include the traditional sensing elements, but also integrate processors and pre-trained AI models. The BME688 is the first smart gas sensor that can load AI models directly. Now, let's look again at this HuskyLens Vision AI module. It doesn't just output image data, it tells you directly, here is a box, or here is a face. This leap from raw data to semantic results is the true core value of AI sensors. They not only see, they also understand what they see. This upgrade in intelligence lets edge devices complete complex perception and decision tasks locally without relying on the cloud. It greatly improves both response speed and privacy security. Alright, let's dive into the core technical differences between AI sensors and regular sensors. First up, we have the algorithmic capabilities. Traditional sensors can only collect data, but AI sensors have built-in algorithms that allow for complex pattern recognition. For example, take millimeter wave radar. The point cloud data it collects can be processed by algorithms to recognize changes in human posture, which then allows it to accurately determine if someone has fallen. Now, traditional sensors usually rely on preset, fixed thresholds to operate. So, for instance, if the temperature goes above a certain point, it triggers an alarm. This approach really lacks flexibility and adaptability. However, AI sensors have the ability to learn autonomously. Take this speech module as an example. It supports 17 self-learning commands. Users can train it personally, adapting to their own accent and needs. Even more powerful is multimodal fusion. By combining speech recognition and speech synthesis modules, it not only understands commands, but also responds with voice feedback, forming a complete interaction loop. When it comes to data processing, ordinary sensors follow a linear flow: collect, transmit, external processing, then action. AI sensors, however, use parallel flows: data collection, feature extraction, pattern matching, and decision output, all happening at the same time. This greatly improves speed and accuracy. Ordinary sensors usually use fixed parameters. Once set in the program, they rarely change, making it hard to adapt to complex environments. AI sensors, on the other hand, automatically adjust to the environment. For example, optimizing speech recognition in noisy conditions. And in terms of power, though AI requires more compute, optimized algorithms and hardware acceleration allow many AI sensors to run with low power, even on long-term battery supply. More importantly, some AI sensors have predictive ability, not only reporting current states, but also forecasting future trends, such as detecting equipment faults or anomalies in human health. This transforms response from passive to proactive prevention. Now, let's see how AI sensors break through the limits of traditional ones. Traditional PIR infrared sensors only detect motion. If a person stays still, they can no longer sense presence. Ultrasonic sensors are affected by environment. In complex scenes, they may cause false alarms or misses. By contrast, AI millimeter wave radar detects tiny breathing and heartbeat signals of a stationary person. Even without movement, it continuously monitors vital signs, able to perceive breathing and heartbeat. In health monitoring, this enables automatic fall detection for the elderly. And in the future, with enough training, abnormal posture can trigger early warnings, predicting the risk of a fall before it happens. For smart interaction, offline speech recognition modules understand user commands. Together with speech synthesis, they form a complete interaction loop, all offline, with no internet needed.
How's the weather today?
Today's weather is sunny and 24 to 27 degrees Celsius. It's a great day for outdoor activities.
Even stronger AI sensors can collaborate. For example, a millimeter wave sensor detects someone nearby, triggers Vision AI for ID confirmation, then the voice module engages in dialogue. This forms a 3D perception system. The change is not just more features, but stronger system robustness. AI sensors stay reliable even in complex and changing environments. Looking ahead, where will AI boards and sensors go? First, edge computing. With lower power AI chips, more processing will run locally, not in the cloud. Second, multi-sensor fusion. A single sensor struggles in complex conditions. but together, multiple sensors make the system far more reliable. Third, ethics and privacy. High-precision millimeter wave can see through walls. Vision AI can identify faces. How we use these powers responsibly is a challenge we must face. In the future, AI boards will enter more verticals, from smart farming to smart healthcare, from industrial automation to environmental monitoring. AI will reach every corner. At the same time, the open source community and education will spread AI knowledge, so more people can join this revolution and create applications we can't yet imagine. AI sensors and AI boards are turning machines from simple sense organs into true cognitive brains. At the heart of this is the deep fusion of algorithms and hardware. From Fire Beetle 2 to Unihiker K10, from millimeter wave radar to vision AI models, DFRobot provides a complete path to practice. AI is no longer out of reach. It's a tool at your fingertips. The future is here. Let's embrace this AI-driven world together. Thank you for watching our video. In the next episode, we'll talk about the shift from centralized intelligence to distributed intelligence. Don't forget to follow us, share this video with those who should know, and leave your thoughts in the comments. We look forward to hearing from you. See you next time. Bye-bye.
DigiKey.